right, so section 1.6 covers problems involving interest, mixture, and uniform motion. So you guessed it, those are going to be word problems. So the first things I want to give us is kind of just a little breakdown of how to translate words into equations. So the first thing we need to talk about is equals. I'm not always going to say equals when I'm telling you that two terms are equivalent, right? I could also say gives or yields or is the same as or is, was, or will be, right? These are all equivalent to saying equals. The same thing holds true when I'm talking about our operations. So for addition, subtraction, and multiplication, I may not always be telling you to add. I might say find the sum. For subtraction, I could say find the difference, or I could say 2 less than x. When it comes to multiplication, I'm going to ask you to find the product. If I say twice, that means I want you to multiply by 2. The one that kind of trips people up is quotient. That's if I'm asking you to find the quotient, I'm asking you to divide. So that's another synonymous term. So when we're solving word problems, the first thing I want you to do is I want you to read the problem really carefully. Ask yourself, what information is missing? What is being asked of me? Next, you're going to need to assign a variable, and just one variable. We only want to have one variable only. And you're going to need to use it to represent an unknown value. Next, you're going to want to sketch it out if possible. Draw a picture. I like making tables. I just personally find that really helpful. You're going to want to write the equation using the variable expression and solve the equation. Step number 6 makes a lot of sense, but it's one of the things that is never done when I give students word problems. And it's state your answer and check, does the answer seem reasonable? When we develop word problems, we want them to be applicable to your, well, maybe not applicable, but representative of daily life as much as possible. So she wasn't driving 200 miles per hour to work. She does not have a height of 75 feet. Make sure that these answers seem reasonable. So in this first word problem, we have Betsy, and Betsy is a recent retiree, and she requires $6,000 per year in extra income. She has $50,000 to invest, go Betsy, and she can invest in B-rated bonds, which pay 15% per year, or a certificate of deposit, also referred to as a CD, paying 7% per year. So how much should be invested in each account in order to collect exactly $60,000 in interest every year? So we're going to use the interest formula. Interest equals principal times rate times time. But right now our time is just 1 year, and everything times 1 is just itself. So we're going to ignore that. I'm going to use a table to organize this problem. But the first thing I need to do is define a variable. So let's let X be the money invested in a B-rated bond. And let's let 50,000 minus X be the money in C-rated bonds. In a certificate of deposit. Now this works if I take the sum of X and 50,000 minus X, I get back to 50,000, right? So here's our principal that we're investing. We're going to invest X, or 50,000 minus X. And if I add these up, I do get 50,000. We're going to ignore this one. Next, I need to talk about my rate of insurance. For B, it's 15%, but we don't want to write that as 15%. We need to write that as a decimal. So I'm going to have 0.15. For my certificate of deposit, it's 0.07. And I'm going to multiply these together to find my interest. And the total amount of interest has to add up to $6,000. So I have 0.15x and 0.07 times 50,000 minus x. So the sum of these two has to equal this. So let's go ahead and solve that problem. I have 0.15x plus 0.07 times 50,000 minus x equals 6,000. And we're going to go ahead and solve for x. So 0.15x plus 3,500 minus 0.07x equals 6,000. Now we can go ahead and combine like terms. 0.08x plus 3,500 equals 6,000. I subtract 3,500 from both sides. That gives me 0.08x equals 2,500. I divide both sides by 0.08, and I get x equals 31,250. So this was the amount of money invested in B bonds. So there was $31,250 invested in B bonds. How do I figure out how much was invested in a certified deposit? Well, I know that that is x minus 50,000 was the amount we would put in a certified deposit. Nope, 50,000 minus x. So if I take 50,000 minus 31,250, that's going to give me 18,750. So $18,750 were invested in a CD. And if she invests this way, she will earn exactly $6,000 a year in interest. This next equation we're also going to need to make a table for, but now we aren't looking at interest rates. Now we're looking at profit. So the manager of a store that specializes in selling tea decided to experiment with a new blend. She's going to mix some Earl Grey tea that sells for $5 per pound and some orange Picote, we'll just go with orange tea that sells for $3 per pound in order to get 100 pounds of the new blend. And I want the selling price of my new blend to be $500 per pound, and there's to be no difference in revenue from the selling of the new blend versus the other individual types of tea. So we have to make sure she's making as much money as she would have made before. So now I'm going to have the pounds of tea, their cost, and the cost per pounds of tea, cost of pounds of tea. Now I know I'm going to have 100 pounds of tea at the end. So let's let X be the amount of orange tea. And that means 100 minus X is going to be the amount of Earl Grey. We'll call that EG. So if I have X pounds of orange tea that normally sells for $3 per pound, and I have 100 minus X of the Earl Grey, which normally sells for $5 per pound, I'm going to have 100 pounds total, and I want each of those pounds to sell for $4.50. So I need 3x plus the cost of the money I'd make off of the Earl Grey to add up to 450. I'm multiplying across. So this has to equal this. Earl Grey is 5, orange Picote is 3. Okay, so if I have 3x plus 5 times 100 minus x equals 450, that means 3x plus 500 minus 5x equals 450. I combine like terms. I get x equals 25. So I'm going to use 25 pounds of orange and I'm going to use 75 pounds, which is 100 minus 25, of Earl Grey. So I've got 25 pounds of orange and 75 pounds of the Earl Grey. This next problem can be solved in multiple ways, and I don't know if I should go through all the different ways it could be solved. I'm afraid it might confuse some of us. So let's say I have Patrick, and he by himself can paint 4 rooms in 10 hours. If he hires April to help, then they can do the same job together in 6 hours. If he lets April work alone, how long will it take her to paint the 4 rooms? So what I'm going to do is I'm going to let 1 be our job is done. So the 4 rooms are painted. Patrick can get the job done in 10 hours. If I add them together, they can get the job done in 6 hours. So how long would it take April? They're going to be doing proportionate work. So the first thing I want to do is have these not be fractions. So I find out that the common denominator of these would be 30a. So if I multiply both sides by 30a, that gives me 3a plus 30 equals 5a. I get 30 equals 2a. If I divide both sides by 2, 15 equals a. So this is one way to solve this problem, where you let 1 be the job done. I did it originally a little differently, and I got the same answer. So why don't I go ahead and show you that? We'll change colors too. So Patrick can paint 4 rooms in 10 hours, right? And Patrick plus Amber, is her name Amber? April can paint 4 rooms in 6 hours. This is still rooms per hour. And I know that if I give Patrick some help from April, so X is kind of the work done by April, that it's going to add up to the job being done. So the first thing I want to do is I'm going to go ahead and simplify both these fractions. Next, I want them to have, I'm going to go ahead and subtract 2/5 from 2/3. That's going to give me x equals, let's do, lowest common denominator here is 15. So I've got 10/15 minus 6/15. I've got x equals 4/15. So remember our denominator was rooms, right? We've got 4 rooms to paint. So April will get 4 rooms done in 15 hours. So that's how I figured out that if April worked alone, it would take her 15 hours if she was alone. So those are 2 different ways to solve this problem. There's actually another one I'm not going to cover because I didn't think it was as straightforward. Like I've said a few times in class, when it comes to math problems, there are many ways to get to the correct end. I don't care which way you go about it unless I specify, and that's really only going to come into play with solving quadratic equations.